Hello and welcome to the first session on C1 and C2 for Triple Science. I'll do 3 sessions on C1 and C2. Now, in this video, we're going to have a look at atomic structure, ions and isotopes, and a bit about the history of the atom. Now, at times you will see this yellow banner appearing on the screen. At that point, I'll ask your teacher to pause the video so you can answer the questions. And a quick reminder that more in-depth videos on these topics can be found on the CHSG Science YouTube channel. They are 15-minute videos on each one, which might be quite useful for some more understanding for you all. If you're ready, we shall begin. So we've got a diagram of an atom, and on that atom we can see various things. We've got the nucleus here in the middle, and we've got electrons orbiting around the outside. And we've got protons, neutrons and electrons that are in here. Our protons are inside the nucleus. They are these red ones that are here with the plus sign on them. They're in the nucleus. They have a charge of +1, that's +1, and a relative mass of 1. Next up, we've got our neutrons, which are the yellow ones inside here, just so we can tell them apart. Again, they are in the nucleus. They've got a charge of 0 and a relative mass of 1 as well. Finally, we've got our electrons. Those are those blue ones around the outside with the minus sign in, and they are orbiting the nucleus. They're going around the nucleus. They have a charge of -1, which is opposite to the protons, and they have a relative mass of 0. They do have a very, very tiny mass, but we don't need to worry about what it is. It is ridiculously tiny. Now we can work out the number of protons, neutrons, and electrons there are in an element. I've got here, we've got possibly my favourite element, we've got lithium, got the chemical symbol for it there, and then we've got these 2 numbers as well. And those 2 numbers tell us different things. We have our one here, which is our atomic number, and that tells us the number of protons within an element, or within the nucleus of an element. And our one at the top, the larger number, we have the mass number, and that tells us the number of protons and neutrons. It also tells us how heavy it is compared to carbon-12. So we always compare it to carbon-12, another element. You can see how heavy it is in relation to that. Now, to work out the number of protons, neutrons and electrons within an element, we have various things to do. So to work out the protons, we look at the atomic number. So for our protons on lithium, we look here, and we've got 3 is our atomic number. So we have 3 protons. Now our electrons on an element are the same as the number of protons, as long as it's not an ion. Because we have 3 protons, we have 3 electrons. And this means that the charge on an atom is 0. We've got 3 positive charged particles and 3 negative charged particles, gives us an overall charge of 0. And neutrons, slightly different. We need to do our mass number, our number up here, take away our atomic number. We'll do that one. We've got our mass number is 7. We're going to take away 3, and that will give us 4. Please pause the video now and complete these questions. You should now have completed those questions. Mark your answers and check for any mistakes and change your mistakes, or change your answers so they're correct. We're now going to have a little look at electrons and what's going on with them. So electrons orbit the nucleus in different energy shells. They're not in the nucleus itself, they're going around the outside. And we have a pattern that we can follow. In the first shell, we can fit 2 electrons before we start on the next level up. In the second shell, we can fit 8 electrons before we can start on the next level. In the third shell, we can fit another 8 electrons before we start on the next one. For GCSE, we only need to know up to the first 20 elements, so we need to know the next 2 as well. We only were about 2 electrons for that. Now, very helpfully, we think about the periodic table. The group an element is in tells you how many electrons are in the outer shell. And that comes very, very useful. We'll see in the third video when we start looking at reactions between different atoms as to what's going on there. So let's have a look at lithium. Lithium is in group 3. So we'll just write lithium here. We've got a 3 and a 7. The number we're interested in is our number 3. Now we'll remember on our first shell we can fit 2 electrons, and on our next shell we can fit 1 more electron. We only need 1 more. We could fit 8, but we only need 1 more to give us that total of 3. Let's look at chlorine. Now chlorine, we've got our Cl, and then we've got 17. And then 35.5 up here. So chlorine, we've got Cl. On that first shell, we can fit 2 electrons. On that next shell, we can fit 8 electrons. And on our next shell after that, we need to get the rest of our electrons. So we've drawn 10 so far. I need to draw 7 more. Chlorine is in group 7, and we've got 7 electrons in our outer shell. Last up, we have neon. And neon has an atomic number of 10 and a mass number of 20. So if we draw our electron shells for neon, again we have 2 in that first shell. And we can get another 8 in our next shell. That gives us a total of 10. And we've got a full shell. So we can say it's either in group 8 or group 0, depending on how we want to look at it. I'd now like you to pause the video to draw the answers for these questions. You can now see the answers on the screen. Our nitrogen has 5 electrons in its outer shell. Aluminium has 3 electrons, and our helium has 2 electrons. We're now going to have a look at ions and isotopes. So, people often get these mixed up, but ions are atoms that have either lost or gained electrons. And they'll lose or gain those electrons to have a full outer shell. Metals will lose electrons and have a positive charge. Non-metals will gain electrons and have a negative charge. So we're going to have a look at lithium. We'll remember that lithium has 3 electrons. And this is it as an atom. To become an ion, we're going to lose one of those electrons. We've lost it there. To show that it's become an ion, we're going to draw a bracket around it and write the charge. It's lost 1 electron, so it has a +1 charge. We're now going to have a look at oxygen. Oxygen is in group 6, so it will have 6 electrons in its outer shell. To become an ion, it's going to gain 2 electrons because it is a non-metal. We'll draw it again. We've got our 2 electrons first. My 6 that I already had. and then my 2 more electrons. Again, to show it's become an ion, I'm drawing my brackets around it, and I'm going to work out my charge. I've gained 2 electrons, so I have a charge of 2 minus, because my electrons are negative. Now, isotopes are versions of atoms that have a different number of neutrons, just the neutrons that have changed. The number of protons will be the same, and the mass number will either increase or decrease. If we have a look at carbon, carbon on the periodic table has an atomic number of 6 and a mass number of 12. So we have 6 protons and 6 electrons, and our neutrons, we do 12 take away 6, which equals 6 neutrons. We have a look at carbon-13, which is an isotope of carbon. We have, again, 6 protons. Notice the proton number hasn't changed. The atomic number doesn't change. And our mass number is now 13. It's gone up 1. So to work out our neutrons, we'll do 13 take away 6, which equals 7 neutrons. We have a different number of neutrons. However, the element will still act in the same way in terms of how it reacts with things, because the number of electrons is the same. So please pause the video and answer these questions. You should now be ready to mark your answers. Mark your answers and correct any mistakes. So we're going to have a look at the history of the atom. Now, we have done this in one of your intervention lessons. There is a whole video on that as well if you want to know more about it. I'm going to start off back in 400 BC with this guy, Democritus. And he decided that all elements were the smallest things we could divide, or atoms were the smallest things we could cut things up into. We keep cutting it smaller and smaller and smaller, eventually we get to an atom. And people were happy with that and went, okay, that's fine. And then around in about 1800, we had this guy called John Dalton. And he came up with the idea that atoms were tiny, hard spheres. And they were indivisible, they were indestructible, they were the smallest thing that could exist. And people, again, were pretty happy with that. It matched up with what we knew. It helped with the development of the periodic table, that all elements had a different atom. Until we got to the late 1890s, and we had this guy, J.J. Thomson. First scientist with a pretty decent moustache, I think. And he discovered the electron, which was something smaller than the atom. And it caused a bit of an issue in science. He found this small thing that was like, oh yeah, it's an electron. It's part of an atom. And he came up with the idea of what we call the Plum pudding model. And the Plum pudding model tells us that we have a positive sphere with electrons embedded in it. Called it a plum pudding because back in the Victorian times they had these things called plum puddings, which was a pudding, a bit of sponge with plums in it. Just like this idea here. And that was all well and good until this guy came along. Ernest Rutherford. Caused some problems for J.J. Thomson. Not least his moustache was an awful lot better. And along with some of his colleagues, he did the gold leaf experiment, or gold foil experiment. They shot An alpha particle, you remember from physics that an alpha particle is just the helium nucleus at a very thin sheet of gold. And noticed that some of the alpha particles got reflected back, they got repelled away. So he made some observations. He said we have a small positive nucleus. He said we have electrons around the outside, or electrons around the nucleus in clouds. And that an atom is mainly empty space. An atom is mainly just empty space. He's done this through experiments. And this is what we call the nuclear model of the atom. And we're getting somewhere to what we know today. A few years later, this guy called Niels Bohr, no moustache on him, he was a lot younger, also from Europe as well as opposed to Britain, like the previous three. And he said, actually, no, they're not going round just in clouds with the electrons. He said, actually, the electrons are in shells. And it's where we get this idea of the 2 in the first shell, and then 8, and then 8 again. Now, a little bit later, we had this guy called James Chadwick in the 1930s, who discovered the neutron. And this led us to the idea of the mass number and how we can get the atomic number and mass number being slightly different, and helped us develop our periodic table as we have it today. So I'd now like you to please pause the video and fill in the missing words on the history of the atom. The answers will now be on screen. You can mark your answers. This video will be available on the CSHG YouTube channel, along with other ones on atomic structure, ions, isotopes, and the history of the atom. Thank you very much for watching. Have a great day and good luck.